So moving ahead with the next one, that is sixth question. A body starts from a point and returns back to the same point. Initial position and final position remains same. Average velocity is, displacement is 0. Displacement is 0, velocity is also 0. So average velocity is 0, but not average speed. Of course, the first statement is true. Average speed is 0? No. So average velocity is 0. So given not. So first, second statement is wrong. Both average speed and velocity are 0? No. Only velocity is 0. Speed is not 0. So third also wrong. Average speed and velocity depends upon the path. What path? It's very clear, of course, but very clear. The first statement gives the accurate answer. Reason. Hence, the only correct option, possible option is first option. Average velocity is 0, but average speed is not 0 because it covers some distance upon time. Moving ahead with the next question, that is seventh question, children. A man leaves his house. So a man, house is there. Okay. Yes. And a man leaves his house for a cycle ride. He comes back to his house. So leaves his house and again comes back to his house. After half an hour, time taken is, distance is equals to, from here to here, let us consider S, and again back he travels at a distance of S. And time is given as half an hour. So 1/2 hour. Distance is 2S. Let us consider distance or traveled is 2S. What is the displacement? He starts from house, leaves the house and again comes back to his house. So here displacement is 0, but distance is 2S. Okay, writing all the conditions. A distance of 1 kilometer. Yeah, covering a distance was also given 1 kilometer, not 2S. So let us take this distance as 1 kilometer this way. Overall, it is given as 1 kilometer. Man leaves his house for a cycle ride. He comes back to his house after half an hour, covering a distance 1 kilometer. That means here he has half kilometer and back half kilometer. Total distance covered is 1 kilometer. But initial position and final position remains same. Displacement is 0. This is the given condition. What is his magnitude of average velocity? Average velocity means you have to take only displacement, children. So displacement, average velocity is equals to total displacement to that of total time. So what is the displacement? 0. Upon some time, how much time? They gave half an hour. Anything by 0. Sorry, 0 by anything, it's 0 only. So average velocity is 0. So second option is true. That's it. Well, let us move to the one more question. That is eighth question. The numerical ratio of the velocity to the speed of a particle is always, this is always, we have already solved this, children. As we know that the magnitude of displacement is either less than or equals to the value of distance. Let us divide this with the time and hence this also with the time, with respect to time. Displacement upon time gives your velocity, magnitude of velocity must be less than the value of speed or magnitude of speed. If velocity is less than or equals to speed, numerical ratio of velocity to the speed, this implies magnitude of velocity to that of the speed is less than or equals to 1. Therefore, the only correct option is the ratio of numerical ratio of velocity to the speed of a particle is always less than or equals to 1. So, third option must be true. So, let us look at the ninth question, children. A stopwatch is used to time t the motion of a car. Stopwatch is started, the car is in motion. At time t1 equals to 12 seconds, some time has passed, that is 12 seconds. The car is at x1 equals to 50 meters. So, 12 seconds, car traveled 50 meters. After 12 seconds, the car is at 50 meters. And at 15 seconds, the car is at 5 meters. Find the average velocity. So, average velocity is given as total displacement by total time. So, this total displacement is some initial position, some final position with respect to the x-axis they have considered. So, position vectors displacement is nothing but final position minus initial position. This is the net displacement. So, started at some point, ended up at other point, and it was measured from origin. So, between the two intervals, this is your origin, started at where 12 x1 and here it is x2, and this is given as 50 meters and here it is given at 5 meters. Reverse way it is going. $50 meters and here is 5 meters. That's it. So, from this position, the particle is moving in this direction. The average velocity of the car is how much displacement upon the time between these two intervals. The formula for this is x2 minus x1 by t2 minus t1. What is the value of x2 given, children? 5 meters. And value of x1 is given as how much, children? 50 meters upon time interval. He started T2 is 15 seconds and T1 is 12 seconds. So, simplifying this, we have minus 45 upon 3. So, this further simplification gives minus 15 meter per second. Therefore, the correct option is option 4. Moving ahead with the next question, children, that is 10th question, similar to the previous one. A particle is moving along x-axis. T1 time 3 seconds, position is 6 meters. T2 time 8 seconds, position is 21 meters. Magnitude of average velocity. Same like previous value. Average velocity, change in position to the total time taken, T2 minus T1. x2, they gave it as 21 meters, x1 6 meters, time 8 seconds upon minus 3 seconds. And this is 15 upon 5 and this is found to be 3 meter per second. Therefore, the correct option is option 3, 3 meter per second. Let us also move to the last question, 11th one. A car travels a distance of 200 kilometers from Delhi to Ambala towards north. Which direction is the car moving, children? The car moving straight north direction, north. So, the car has started its journey from Delhi, D, and Ambala, A, moving in the north direction. The time taken is 5 hours. The velocity of the car is, so velocity of the car is nothing but the total distance to the total displacement to the total time. Displacement is given as magnitude of the displacement is given as 200 kilometers and direction is upward, that is north side. Direction is towards north. So, velocity can be given as total displacement to the total time. Displacement is 200 kilometers and time taken is 5 hours. And this is calculated as 5 4s 20. So, this is found to be 40 kilometer per hour. So, velocity is how much, children? 40 kilometer per hour. Which direction? North direction. So, the correct option is option 3, that is 40 kilometer per hour towards north. So, with this we have completed with the worksheet number 3 of kinematics. So let us meet in the worksheet number 4 in the next class. Until then, take care. Thank you.